On March 11, 1958, a new era in manufacturing production was born. For the first time in the history of manufacturing, a number of large production machines, electronically controlled, were functioning simultaneously as an integrated production line. Virtually unattended, these machines were drilling, boring, milling, and passing unrelated parts from machine to machine. End products were processed from rough castings through 3 complete and different cycles of machining operations, entirely independent of human intervention. Taped instructions guided the precision movements of the machine tools, and the electronic system maintained complete and unerring control of all operations during the 3 separate manufacturing cycles. The story behind this revolutionary electronic control system began in 1955, when a group of Hughes Products engineers, highly trained and experienced in commercial applications of electronics, investigated the possibility of producing a numerically controlled machine tool line, which would offer complete versatility rather than the single product limitation of the so-called Detroit-type machine. As the research progressed, desirable features of a system equally adaptable to limited production runs in small machine shops as well as large-scale operations were carefully charted and investigated. Exhaustive studies were made of standard machine tool performances. Step by step, the requirements for making these tools completely automatic were satisfied. And a highly versatile, electronically automated machine line, an industrial breakthrough, became a reality. To fully understand the operating procedures and built-in simplicity of the system, let us start at the beginning of a production project. From a blueprint, all factors of operation, including speeds, feeds, and coolant controls, are entered on the planning sheet. The planner thus has control of all variables. After the operations and adjustments have been recorded on the planning sheet, it is taken to the tape preparation unit. This unit consists of a simplified keyboard and 2 punching and verification units mounted at the sides. The design of the planning sheet is duplicated in the keyboard layout so that only minimal training is necessary for operating this unit. As the operator types the information from the planning sheet, keyboard sections are illuminated. If the information is typed in proper sequence, the lights go out. If they remain on, the operator is alerted that a mistake has been made. When all information for a machining run has been typed, the keyboard punch bar is depressed and the information is electrically converted from decimal form to a plastic tape. When complete manufacturing data has been transposed to a single tape, it is ready for the tape reading unit, which electronically reads the information on the tape to the computers. To eliminate the possibility of any errors during the reading process, a special parity check electronically warns the system of incorrect readings. If an error occurs, the machine is halted until it is corrected. As a further safeguard, a system of watching the watchman is used. A built-in planned error system operating on a time pattern challenges the tape reader at predetermined intervals to ensure that the parity system is operating. As the tape is being read, checked, and rechecked by the tape reading unit, the data are being assimilated by the electronic control units. These highly sensitive yet compact electronic brains can also be storing additional information for the next machining run. Containing the latest innovations in miniaturized circuitry and modern construction, these electronic control units use diodes and transistors rather than vacuum tubes. thus providing maximum reliability with minimum power requirements and greater compactness. Maintaining meticulous surveillance and control of the entire manufacturing process, the computers, dictating electronic instructions, produce swiftly and steadily part after part after part with extreme accuracy and reliability. Another unique feature, the positioning and measuring unit, further increases the system's reliability by monitoring all actions of the machine tool elements. During a recent test period, 8 billion counts were measured by this remarkable unit without error. However, the most significant features of this production system stem from the collective advantages gained through its flexibility and versatility, with perhaps the most important of these being its ability to control any number or variety of production machine tools, coupled with its complete adaptability to small lot production. Not to be overlooked is the fact that taped instructions for setups and machining runs for one part or 10,000 can be stored, then used again and again. And each time, the faultless accuracy of the original machining will be duplicated. Ideally suited for the fast-paced changes and shorter runs which constitute the bulk of today's industrial production, these versatile electronically automated controls will, in the future, be monitoring virtually all phases of production, from part setup to final inspection.